Alright guys, let's continue with the last few problems. Number 30, use the table to answer the following questions. So in the table we see that Ninja Turtles are $25 each, princesses, these are Halloween costumes, princesses are $40 each, and superheroes are $37.50 each. Kathy bought X number of Ninja Turtle costumes for her kids. Write an expression for the cost of the costumes. So if she write an X number, we don't know how many, X, and they're $25 each, right? That's what it says right there. Ninja Turtles are $25 each. The cost of her costumes is going to be 25X. $25 per costume, depending on how many she bought. Part B says, Nick bought 2 princess costumes and Y number of superhero costumes. Nick spent less than $200. Write an inequality that shows how much Nick spent. So he bought, let's break this down, 2 princess costumes. So 2, and each one of them is $40, so 2 times 40. That's the first thing we're going to write, 2 times 40. 2 because, and each one is $40. But on top of that, Y number of superhero costumes. So superheroes are $37.50 each, so $37.50 Y. $37.50 times Y. He spent less than $200. Less than $200. So the total between the 2 princess costumes and the Y $37.50 princess superhero costumes is less than $200. There's the inequality. 31. A building casts a 103-foot shadow at the same time that a 32-foot flagpole casts a 34.5-foot shadow. How tall is the building? Round your answer to the nearest tenth. So what we don't know is the height of the building. We'll call that X. This is X. What we do know is that the shadow of the building is 103 feet. Okay, 103-foot shadow of the building. So 103 is the distance from here to here, 103. And the height of the building, once again, is it's X. For the flagpole, we know the height of the flagpole, 32 feet right there. And we know its shadow is 34.5. So using those, what we have is basically a big triangle like that here, and a small triangle right there. So what we're going to do is set up a proportion. Okay, we're going to start with X over, we've done this something like this before in the previous review. X over what? It's got to be something that makes sense with X. The only one that pairs up with X, there's actually 2 of them, is 103 because they're both about the building. Also, you could use 32 because they're both about the height, right? So X over 32 since they're both heights, or X over 103 since they're both about the building. It has to be something that is related to X. Let's go with 103. For the other proportion, the other ratio, we need to keep up the same pattern. So if I did X, which is the height, over 103, which is the shadow, over here I have to do height over shadow also for those numbers. So 32, which is the height, over 34.5, which is the shadow. And using that, we can solve this problem now. We're going to cross multiply. So 34.5x equals 32 times 103. Divide by 34.5. Oh, we need to multiply that first, don't we? All right, I'm going to write the division already there, and then I'll just do everything at the same time. So what I'm going to do is multiply these 2 and then divide by 34.5. So let me pull out the calculator and do that. My calculator says 95.5 feet. It says round your answer to the nearest tenth, so that's perfect. 95.5 feet is my answer. Let's check if that makes sense. Look at the flagpole. The height of the flagpole is smaller than the shadow. The length of the shadow is longer, right? So the shadow of the building should be longer than its height, and it is. The shadow is 103, the height is only 95.5. So that makes sense. All right, let's move on to 32. It says graph the following functions. For 32, 2x plus y equals 3. So they want us to graph it. Now, this one is not ready for graphing. Okay, ready for graphing means that the y is isolated. You want the y to be by itself. So that's what we're going to do first before we start trying to graph it. We're going to isolate the y. So I'm going to solve this for y. This was pretty easy to solve. All you got to do is get rid of the 2x. And to get rid of it, since it's being added here, we're going to subtract it. Minus 2x. So they're both gone, leaving me with y equals 3 minus 2x or negative 2x plus 3. Either way is correct. If you write it like this, it's also correct. Okay. What is not correct is to say 3 minus 2 is 1 and write 1x. That is not correct because they're not like terms. Okay. So I'm going to write it as negative 2x plus 3, this one. And now what I'm going to do is I'm going to make a table of values to graph it. So I'm going to make an xy table. Choose some values for x. The common 5 that I told you guys to use, negative 2 through positive 2. Negative 2 through positive 2. And what you're going to do is you're going to plug them all into here. Okay, so let's start with the first one. I'm going to plug in negative 2. Y equals negative 2 times x plus 3. Plug in negative 2, see what you get. Negative 2 times negative 2 is 4. 4 plus 3 is 7. So that gives you 7. Do it again. Y equals negative 2 times x plus 3. This time I'm plugging in negative 1. Right, I'm doing this one. See what I get. Negative 2 times negative 1 is 2. 2 plus 3 is 5. Y equals 5. The next one, plug in 0. Y equals negative 2 times 0 plus 3. I'm going to plug in 0 right there. That's going to give me 0 plus 3, which is just 3. So 3. Keep going. Plug in 1. Y equals negative 2 times x plus 3. Plug in 1. So y equals negative 2 times 1 is negative 2, plus 3 is just 1. That gives you 1. And the last one, y equals negative 2 times x plus 3. We're going to plug in 2. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1. There you go. You take those points and you plot them on the graph and you're done. So negative 2, 7. That means go left 2, up 7. It doesn't really fit, but it's not that far away, so I could actually put it right there. Negative 2, 7. Negative 2, 5, 6, 7. About right there. It's an approximation. Negative 1, 5. Left 1, up 5. Right there. 0, 3. Stay on the center. Do not go left or right, but go up 3. 1, 1. Right 1, up 1. 2, negative 1. Right 2, down 1. And then you connect them. You always connect functions. If they don't tell you that there's a certain domain you have to use, just connect them together. It's going to be continuous. And you're done. Alright, let's do the same thing with number 33. They already started a table for me, which is great. All I have to do is just plug them in. Okay? But we have to do the work. So let's plug in negative 10 to start with. So this is what it's going to look like. F of x, which is negative 10, equals negative 1/5. Let me erase that. That looks horrible. Negative 1/5 x plus 3. So let's start plugging in numbers, starting with negative 10. I'm going to write in negative 10 over 1. Since it's a fraction, the negative 1/5, I want to make sure I can do it. Alright, so what I have is negative times negative, so it's going to be positive. I know that. 1 times 10 is 10. 5 times 1 is 5. So it's 10/5 plus 3. 10/5, that's 10 divided by 5. That's 2. So it's just 2 plus 3, which is 5. You get 5 for that first one. Let's do it again and plug in negative 5. So erase all this. I'm going to put in negative 5 right there. So negative 5, once again I'm going to plug it in as a fraction. Negative 5 over 1. It's going to be negative times negative, so again it's going to be positive. 1 times 5 is 5. 5 times 1 is 5. Right? Numerator times numerator, denominator times denominator. Plus 3. 5 divided by 5 is just 1. So it's just 1 plus 3, which is just 4. Done with that one. Let's do it again with 0. 0 is real easy, actually. Just plug in 0. What happens when you multiply by 0? You get 0. Plus 3 is just 3. Plug in the next one, which is 5. Let's plug in 5. Put a 5 there. In this case, it's a positive times a negative, so it's going to be negative. So it's going to be negative 5. This is 5 over 1, by the way. 5 over 5, right? Numerator times numerator, denominator times denominator. Plus 3. That means negative 1, because negative 5 over 5 is negative 1 plus 3, which is 2. So that gives you 2. And the last one, which is 10. Plug in 10. Negative 1 over 5 times 10 over 1. That's negative 10 over 5 plus 3. That's negative 2 plus 3. That's 1. There you go. Those are your points. All you got to do now is just plot them to get the final graph. So it's going to be negative 10, 5. That means 10 to the left, up 5. So 10 left, 7, 8, 9, 10, up 5. It's like way up here. So it's off the graph. Okay, the other ones should fit though. Negative 5, 4. That means 5 left, 4 up. Right there. 0, 3. Stay in the middle, go up 3. Right here. 5, 2. Go 5 to the right, go up 2. And 10, 1. 8, 9, 10, 1. Right there. And you connect them to make your line like this. There you go. That's your final graph. Okay, 34. A statue of Rocky Balboa casts a shadow that is 16 feet long. A 6-foot tall Mr. Cabrera casts a shadow that is 8 feet long. Which proportions can be solved to find the height of the, not the pole, that's a mistake, of the statue. I should say statue. Okay, so let me draw a quick diagram here. What we have is a statue, that's a statue, and its shadow, right? The statue, we don't know how tall it is, but its shadow is 16 feet. And then what we have is a person, Mr. Cabrera, and his shadow. Mr. Cabrera is 6 feet tall, but his shadow is 8 feet long. So using that, I can figure out the height of the statue, right? We got to figure out x. That's the goal, to figure out the height of the statue. So we're going to set up some proportions. Starting with x, remember what I keep saying about these. You got to figure out what number to put under x that makes sense. Okay, so in this case, what makes sense to put under x is 16 and also 6. Those are the only ones that put with x that work by putting them under x or with x, right? 16 because they're both about the statue, 6 because they're both heights, right? So I can put x over 16 equals, now if I do x over 16, that's this over this, then I have to use these other numbers in the same order. So height over shadow, 6 over 8. That is a proportion that can be solved, that would work. I see that that is A, so A is yes. The question is, can any of these proportions be solved to find the height of the statue? A can work. Let's try another one. What if instead of x over 16, I chose the other number that also goes with x, which was 6, right? X over 6. Again, why that one? Because they're both heights. X over 6 equals, since I'm doing height of statue over height of person, I'm going to do the same thing on the other side. Shadow of statue over shadow of person. 16 over 8. And I'm going to look to see if that one is there. And it is not there. I don't see it at all. All I see is x and 16. Okay, so I guess we have to go through all of them. Let me write down the one that we already came up with. X over 16 equals 6 over 8, right? Which was A. Let's look at B. X over 16, same thing, but they flip the 8 over and the 6. So that's definitely no. They have the exact same correct thing on the left, but the right is wrong. The right side is wrong. In C, what they did is they flipped the X and the 16. That's okay. They can do that as long as they also flip the right side. And it looks like they did, right? 16 over X, 8 over 6. Right here. Look, it's the same thing as this one, but flipped. So that one is yes. And D, they also flipped it, but they did not flip the other ratio on the other side. Okay, so it's the reciprocal of this, but it's not the reciprocal of that. So that one is no. So the only two that can be solved in these options are those two. This one is also correct, but it's not there, so we don't have to worry about it. Okay, last problem, 35, conversions. Steve is getting ready for his big race. He's hydrating by drinking water at 4 ounces per minute. How many ounces is he drinking per hour? So they want us to convert ounces per minute to ounces per hour. So I don't have to convert the ounces, I have to convert the minutes to hours, right? So 4 ounces per minute, what I have to do is figure out how many minutes in an hour. 60, correct? So what I'm going to do is convert that number. 4 ounces per minute. So what I'm going to use here is a conversion factor, okay? What I have is 4 ounces. Oops, my mistake. I have 4 ounces in 1 minute. That's what I have. But my goal is to have ounces over hours, right? Ounces per hour. So I'm going to convert by multiplying times another ratio, basically this one, to see if that solves it for me. 60 minutes, the minutes and the minutes will cancel out, right? It's the same thing in the numerator as the denominator. Numerator, denominator, they cancel out. So basically I'm just going to multiply 4 times 60, which is 240. Minutes cancels minutes. And what's left is ounces, they did not cancel, and hours. 240 ounces in 1 hour. How do I do that again? A sumo wrestler is looking to lose some weight. He goes on a diet and loses 3 pounds every 2 weeks. That's what that means, 3 pounds for every 2 weeks. If he keeps his weight loss consistent, how many pounds will he lose in 1 year? Hint, how many pounds will he lose in 1 year? Hint, 52 weeks is the same as 1 year. Okay, so what I have to start with is 3 pounds, 2 weeks. What I want is pounds, year, right? How many pounds in 1 year? So what I need to do is multiply the 3 pounds, that's the symbol for pounds, in 2 weeks, times something that will allow me to convert. I don't need to convert pounds, right? It's already pounds what I want. What I need to do is convert weeks. Weeks needs to change into years. So I'm going to use this. 52 weeks is 1 year. So I'm going to put 52 weeks up here, 1 year down here. Why that way? Because that way the weeks and the weeks cancel. And what I have left is going to be pounds and year, which is what I want. 3 times 52 is going to be 156 pounds. And 2 weeks times 1 year, that's 2 years. We don't want 2 years, we want 1 year. So 156 divided by 2 would give you 78 pounds in 1 year. That is the correct number.